Hey everyone, hope you had a good weekend. I'm gonna go over some proof review. Kind of do three. We're gonna do three proofs today. We're also gonna go over all the postulates and theorems that we've kind of seen and picked up and learned as we've gone through this chapter, just so we kind of reinforcing and remembering um, what we need to be using as we're going through our proofs. Trying to get ready for our test on Friday and Monday. Um, so like I said, we're gonna do three proofs today at the end of class and at the end of this presentation. I want you to take some time to try to step through them all yourself um, before you kind of watch the videos as it goes through, just to see if you can piece it through, because there is going to be one proof on test that you are going to have to go through yourself, start to finish, to make sure that you have and understand how to do it. So I want you to practice with these today. Again, I'll have all the answers in the video, so you'll be able to see what you've done. But I just want to make sure that you guys kind of have an idea what's going on. Um, so then on Tuesday, I'll be passing out a review packet. You'll get that Tuesday when you start class, so you can kind of go through and start working on all the stuff that the test is going to be on with the algebra problems, with some of these postulates and theorems, filling in the blank on some of the proofs, um, and then doing some actual proofs as well, just so you kind of get in practice with that. I have a bunch of problems that we can kind of pull together and do that with as we go through that. Wednesday, we'll do an online Zoom thing where anybody can ask any questions they have. We'll kind of go over, um, maybe go over some of the stuff from the review packet as we're going through. Um, but it might be more a situation where you'll kind of look at everything and see where we are to kind of get through that. And then Thursday, going to be a little more in class review for the kids in class. Thursday, so you can ask me specific questions that you weren't able to ask over Zoom meetings or just didn't want to do it that way. And like I say, Friday will be the test, the written part in class for cohort B. Cohort A will take the online version on Friday, and then it'll flip on Monday. So let's get going on our stuff. So like I said, we've gone through a lot of postulates and theorems for this chapter. So here are the first 7 postulates we learned that are mostly dealing with line segments. We learned even in last chapter that through any 2 points, there is exactly one line, and only one line. Postulate 2.2 was through any 3 non-collinear points, there is exactly one plane. Postulate 2.3, a line contains at least 2 points. Postulate 2.4, a plane contains at least 3 non-collinear points. Postulate 2.5 is if 2 points lie in a plane, then the entire line containing those points lies in the plane. 2.6, if 2 lines intersect, then their intersection is exactly 1 point. And then 2.7, if 2 planes intersect, then their intersection is a line. Again, stuff we learned in the last chapter with the basics of geometry, reinforced here with the postulates to prove that it's a given statement in geometry. That's why they're always true. The test problems will kind of be what we saw before a little bit with is it true, is it not true based on the stuff, and then we'll kind of go from there. Segment addition postulate. This will be something that we're going to need if we have a segment proof. If A, B, and C are collinear, remember they have to be collinear, then point B is between A and C if and only if AB plus BC equals AC. What we're saying there is that they are adding up. As we know, the segment addition, the 2 line segments can add up to be the length of the major segment. And that's the way we know that the point B is between those 2. The reflective property, again, this will also work with angles, that AB is congruent to AB, or segment AB is congruent to segment AB. The symmetric property, if segment AB is congruent to segment CD, then segment CD is also congruent to segment AB. It's just kind of flipping them around, understanding that we might have to do that just to kind of get our stuff in the right order. And then the transitive property, again, the logic statement, if A equals B and B equals C, then A equals C. In geometry of the world, it looks like this, that if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to EF. Again, works with angles as well. The angle addition postulate, similar to the segment addition, R is in the interior of angle PQS if and only if the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. So the two smaller angles must add up to equal the big angle if R is in the interior. The supplement theorem, if two angles form a linear pair, then they are supplementary angles. The complement theorem, if the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. Remembering that supplementary and complementary are 180 and 90 degrees. Congruent supplement theorem, angles supplementary to the same angle are congruent, or congruent angles are congruent. So if there's two separate angles that are supplementary to the same angle, then they're going to be congruent. If they're supplementary to two angles that are congruent, then those angles are going to be congruent as well. Works for complementary as well. Congruent complements theorem, angles complementary to the same angle or to congruent angles are congruent. And then the vertical angle theorem, if two angles are vertical angles, then they are congruent. Theorem 2.9, we talked about perpendicular lines. Perpendicular lines intersect to form four right angles. 2.10, similar to that, all right angles are congruent. So perpendicular lines are going to form congruent angles, which is the next theorem. Congruent adjacent angles. And then we know too that perpendicular lines, if they're intersecting and crossing, then they're going to form congruent vertical angles as well. If two angles are congruent and supplementary, then each angle is a right angle. That makes sense because if they're congruent, they're going to have the same measurement. They're going to be supplementary, so they're going to add up to 180 degrees. So they're both going to have to be 90-degree angles if they're congruent, so they're right angles. And then if two congruent angles form a linear pair, then they are right angles. So I think all these make sense, and we kind of use them as we kind of pushing some stuff through. When you're doing your proofs, you can either use the theorem 2.313 or basically just say what they are. Definition of linear pair angles, things like that. As we're going through a proof, you'll see that today. The corresponding angles theorem. If two lines in a plane are cut by a transversal, so we're always talking about two lines in a plane, and they're being cut by a transversal, and the corresponding angles are congruent, then the lines are parallel. What these theorems are doing is taking our corresponding angle information that we know and kind of proving that the lines are parallel. The alternate exterior angle theorem, if two lines in a plane are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. So again, trying to prove lines are parallel. Consecutive interior angle theorem, if two lines in a plane are cut by a transversal and the consecutive interior angles are congruent, then the lines are parallel. Remember, consecutive interior angles are the angles that are on the same side of the transversal inside the two lines that are potentially parallel. So they're inside the two lines that are being cut by the transversal, but they're on the same side of the transversal. Alternate interior angles theorem, if two lines in a plane are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Remember, alternate interior angles are the lines that are inside the two lines being cut by the transversal, but they're on opposite sides of the transversal. And the perpendicular line theorem, if two lines are perpendicular to the same line, then those lines are parallel. If I remember correctly, I think that was the end of all the theorems, so kind of have that in the back of your mind. Again, I'm going to try to have a printout of this for you for the test so you can kind of have them. I'm not going to make you memorize them all as we go through. You should just definitely be kind of understanding what they all are. And we'll see how we go from there. Proofs. We're just talking about proofs. Remember, we're looking to make a logical chain of statements. So the chain is going to build on the previous statement to get from our given information to the conclusion of what we're looking to prove. So all proofs, we're given some information, we're given a diagram, and then we're told to prove something. Remember, I've always said that what we're trying to prove more often than not, 99 times out of 100, is something that we know is going to be true just because the way geometry works, we're just trying to prove it. I'm not going to give you something that's going to be impossible for you to prove because that's math that hasn't been created yet, and we just want to make sure that we're working with stuff that can be proved. Again, I always say look at the diagram. Try to find out as much true information that you can make and true statements you can make from the diagram between what you're given and then what you can make out from the diagram. Mark up the diagram, like I said, because you're going to kind of need that information to build the proof. And always remember that there's going to be more than one path to complete the proof. Just because I've shown you statements and steps 1 to 5, you might be able to get to that by 1 to 7 or 1 to 8 or even 1 to 4 stepwise. It just has to make sense that it all flows and that everything actually is true and what you're saying is true and has been proven before. So I hope that makes sense. We're going to kind of go through the proofs now. So again, like I say, I'm going to put the proof up with the givens and stuff. The video is going to pause, but then always try to do it yourself before you kind of go on to see if you can do it, because it is something that on the test you are going to be asked to write a proof from start to finish with just the diagram and the given statements and the number of boxes that I'm expecting the proof to take. Okay, so we're given in our diagram, we're given 3 lines that appear to be parallel, and we're given some information. We're given that angle line L is congruent to angle M, or not congruent, I'm sorry. Line L is parallel to line M. We're also told that angle 2 is congruent to angle 3, and we're trying to prove that angle L is parallel to line M. I'm sorry, to line P. So prove L is parallel to P. And then Q is the transversal. So we're kind of looking, we've seen the diagram before when we're talking about like our alternate interior, alternate exterior, and all the angle relationships we were talking about earlier. So I think we might be able to kind of piece together how we're going to do it. They've told us 2 of the lines are parallel, which is great information. They've also told us that 2 angles are congruent, which I think we kind of recognize. We're probably going to have to use that to prove that M and P are parallel. And once we can do that, we might be able to back into the fact that L is parallel to P. So, as I always say, we start with our givens. L is parallel to line M, given. Then we're going to go angle 2 is congruent to angle 3. Again, that's your given. Now we kind of look and say, what do we got going on here? I can say angle 1 is congruent to angle 2 based on the corresponding angles are congruent. Because I know angle L or line L is parallel to line M. They tell me that 2, or from there I know that angle 1 and angle 2 are corresponding angles for lines L and M, so they have to be congruent because they correspond. And we know for corresponding angles from parallel lines are congruent. So then from there I can say angle 1 is congruent to angle 3 via substitution. So the transitive property will go in there. We have A equals B, B equals C, A equals C. That's what we kind of went with there. You also could have said substitution because we can substitute 1 for 2 in the first statement. Again, either one of those would work, transitive or substitution. And now I know if I have angle 1 and angle 3 are congruent, then I can say that angle L is parallel to angle P because of the corresponding angle theorem again. Because I have 2 corresponding angles that are congruent, so that makes my lines parallel. Hope that made sense. I hope you were able to kind of work that one through yourself. Again, if it took you more than 5 steps, don't worry about it as long as kind of all the statements flowed through and looked reasonable. What you can also do is if you want to question it just to make sure, then ask me on Wednesday when we do our Zoom meeting, and we can kind of go over them and make sure everything's good. If you want to send me an email beforehand, then I can kind of use that question to kind of show the whole class, hey, here was another way to do this proof from Monday's class. Okay, we're going to move on to the next one. Again, try to figure it out yourself. Take a few minutes, kind of think it through, see what we're trying to go, see where we're trying to go from, and see if we can get the proof done. Okay, so when we look at what we're given, we're told angle 1 and angle 2 form a linear pair. And then we're told angle ABC is a straight angle. And we're trying to prove that angle 1 and 2 are supplementary. So we're looking at it linear pair, straight angles. It's kind of the same thing. So basically what we're going to be able to kind of tie everything together. We know what straight angles are, how it looks like. We're going to be able to kind of piece this one together, I think, fairly reasonably quickly. So again, we always start with our givens. 1 and 2 form a linear pair. That's a given. What we're going to do is we're going to skip our first given here now, and we're going to actually go to this based on the definition of a linear pair. And we're going to say angle 1, measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC with the angle addition postulate, because we can see that. I can see angle 1 plus angle 2 is going to equal angle ABC. Now I want to come in with angle ABC as a straight angle. That's our second given. So we've kind of put a step in between our two givens, but it does flow through and make sense. Step 4, we know measure of angle ABC is 180 degrees. That is from our definition of a straight angle. We're then able to say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. This is going to be our substitution. We're substituting 180 in for the measure of angle ABC on our statement from line 2. That's what we're substituting into. So it flowed through. We built on a previous statement. That's all we're trying to do. And then from there, angle 1 and angle 2 are supplementary because that's the definition of supplementary angles. Measure of angle 1 plus the measure of angle 2 equals 180 degrees, and then they are supplementary, so we've proven what we were out to prove. Again, I hope that makes sense. I hope you were able to see through that from the start and get through what the statements were. Again, if you took more than 6 steps, don't worry about it. Send me an email making sure it's true, making sure if it worked for you. If you did it in less, again, make sure that everything flowed through and made sense. Like you could have done this one in 5 statements by putting the 2 givens on the first line. Again, still would have worked. It just kind of flowed a little better to kind of pop in the angle addition postulate there between, so we can kind of introduce the measurement of angle ABC to kind of introduce the angle even before it was given. Hope that makes sense. Okay, so now the last proof. Again, take a few minutes, try to work through it yourself, see if you can get from A to B, to get from the givens to the proofs, to prove what we're trying to prove. And then we'll review the answers. I'll be going through the answers here so you can review your work. All right, again, we're looking at angle 1 and angle 2 being congruent. That's what we're given. We're also given that they're supplementary. So we can kind of think there's a postulate or a theorem. We know about that. If they're congruent and supplementary, we know it means something. And then we're trying to prove the right angles. So let's go with what we got. Angle 1 and angle 2 is congruent. That's a given. Line 2 is angle 1 and angle 2 are supplementary. Again, that was another given. So we've gotten the givens out of the way. Now we got to kind of see how we're going to get to where we need to be. So I think we're going to build on supplementary part of it, knowing that. Actually, we'll do it this way first. Sorry. We know measure of angle 1 equals the measure of angle 2 because that's the definition of congruence. We're told they were congruent, so the measurements have to equal. Now we can go to where I wanted to be. So the measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees because, again, that's the definition of supplementary angles. We were told they were congruent. We were told they were supplementary. We've gone into the measurements now, the definition of congruence, and the definition of supplementary angles. Then what I'm going to be able to say, because we have to find to prove that they're 90-degree angles. We haven't been able to do that yet because we don't know. We just know that they equal, the measurements equal. So what I'm going to do now is I'm going to substitute the measure of angle 1 in for the measure of angle 2. This is the substitution property. So we're able to do that because we've proven they were equal. So now I've made them that angle 1 plus angle 1 is going to equal 180 degrees because I know that their measurements are equal. So we're kind of in the algebra side thinking through now, where now I can combine them. The 2 times the measure of angle 1 equals 180 degrees because that's what 1 plus, like, measure of angle 1 plus the measure of angle 1, it's 2 times that now. We can do it that way. So that we're going to call the distributive property because we kind of go backwards. Next, we're going to now say that the measure of angle 1 equals 90 degrees because we're kind of solving the math equation. So we're going to divide 180 by 2 to just leave us with the measure of angle 1 by itself again, and that's the division property. Does that make sense? Hope that makes sense to everyone, because this was a little trickier proof than what we've seen, kinda, but you should kind of have been able to kind of flow it through, I think. Then we have the measure of angle 2 equals 90. We're going to call that substitution property because we're substituting the measure of angle 2 in for the measure of angle 1. And now we've proven that both of the measures equal 90 degrees. So I then can say that the measure, or angle 1 and angle 2 are right angles because of the definition of right angles. If an angle equals 90 degrees, it's a right angle. So again, it was a little different with what we've seen. I hope you were able to work it through, kind of saw the steps and kind of got where it needed to be. I think lines 4 and 5 might have been the tricky part for you to get there. So if you have questions on this one, we'll definitely go over that. I think we'll kind of plan on doing it in class on Thursday when I see you guys the first time, just to make sure you understood where this went. I don't anticipate having a proof on the test that looks like this. But again, right now I can't say I don't know, because I don't know what problems you guys are working on for your test questions either. So that's the end of our presentation. Hope everybody had a good day, and I will talk to everyone later.